Hey guys, welcome to this quick explanation video about the cake tin investigation for Stage 1 Mathematics, and we're through the topic of differential calculus. So what you guys are going to be doing is looking at basically open-ended boxes and how can we come up with a formula that will model the volume of the box based on some measurements. So what you're going to do is investigate the size of a square cut into a piece of tin plate to form an open-top cake tin, which optimizes the volume. So ideally, would want to have the largest volume possible for the size that we're given. So you're going to use various mathematical calculations that involve calculus and the quadratic formula. So it's going to be fairly simplistic in the fact you're using the quadratic formula, and make a conjecture. So we'll talk about that in a moment. So here we've got is our bit of tin plate of length L, and what we're going to do is cut out 4 pieces from it. These are going to be length X, and what we have to do to start with is, given that the length of each side of the tin plate is 8 centimeters, so that's L being 8, show that the volume of the cake tin can be expressed as the volume being equal to 4x cubed minus 32x squared plus 64x cubic centimeters. Now, how do we do this? Well, what you're going to do is look at the length here and try to determine, using what you know about the volume of an object, try to determine or come up with an equation for it. Hopefully you guys will be able to see how that works. So for a little hint to get you started, you're going to need to find this length in here this length in here, which is going to be the same. So these lengths here are all going to be the same. You have to come up with an expression for those, because times width times the height. Now, I'll tell you right now that the height is going to be that x centimeters. You need to then find the derivative of this formula, and when you find the derivative of this formula, it will actually come out as quadratic. So you need to then find the exact value of x, which will maximize the volume of the cake tin. So remember, use a sign diagram for that, and you're looking for a local maximum. You'll get 2 values out from the quadratic formula, one of which will be a local minimum, and the other will be a local maximum. You're looking for the local maximum. If you get stuck, the 2 values that you come up with, plug them back into our original equation here, and see what the answer comes out as. You're going to get 2 answers. Then you're going to do that for the exact value of x, so you're going to again find the exact value of x, which maximizes the volume, for at least 3 other values of L. So you need to do at least another 3 lengths to change 8 to 3, at least 3 other values. Then what you're going to do, and this is going to be the more difficult bit, is present a conjecture based on a square piece of tin plate of side length L, which, when a square is cut from each corner of length x, a maximum volume for the resulting top cake tin, open top cake tin will be obtained. Now, what you're going to have to do for this is look at your length of L and the length of x and see if there's a relationship between them. And I'll tell you now that there is. So have a look through that, see what it is, see if you can work out what that relationship is. Then you're going to do the same for a rectangular piece, and it's exactly the same process as before, just going through and working out the values of x versus the length. So develop a conjecture about the relationship between x and the length of each side. So what you're going to do is determine the length of each side to start with, and then work out a formula. So it's essentially the same as what you do in part A, except instead of a square, you've now got a rectangle. So you're going to have to choose 2 different lengths for the sides. Don't just make one 8 and the other 4, then do another one where the first one's 4 and it's 8. That defeats the purpose. It's not going to work. You're going to have the same answer and not be able to pull any information out of it. So The sides of the rectangle are in the ratio RS, so make R one side, S the other. Consider a rectangle where one side is twice the length of the other, so you might have 5 to 10, or 10 to 20. Find the value of X that gives the maximum volume for the cake tin. Repeat process for tin plates with at least two other ratios. So start off with a 2 to 1 ratio. You might go a 3 to 2 ratio afterwards if you like. Then follow, again, find the exact solution for X using the quadratic formula and develop a conjecture about it. So looking again at the ratio of the sides versus the value of X. And then prove using the principles of calculus and quadratic formulas one or both of the conjectures you found in part A or B if you want to go through and do that further extension stuff. I will talk to you guys about that individually if you decide to go down that path. So again, maximum of 8 pages if written. Now I do want you guys, I'm happy to look at drafts on paper, but I do want you guys to type this up in preparation for next year, where all your assignments will have to be electronically processed. The performance standards are on the back, so have a look through those and see what you think. So it's not an overly long investigation. Hopefully you guys will make a bit of a start on this and get most of it done in a lesson or a couple of lessons. So if you've got any questions, please just see me. Thanks for watching, and we'll